We now go ahead in frequency from the ultraviolet and meet the X-rays. Okay, there the X-rays. It's an interesting story how it came into being. When first it was detected by Roentgen. Okay, he did not know what to name it, so he said, okay, let it be X, as an unknown in mathematics. So he actually called it X rays and thought of naming it later, but this name picked up and it remained as X rays. Okay, so that's how the name came into being. This X was that unknown in the mathematics. Okay, now the wavelength, its wavelength varies from 10 nanometer to 10 to the power minus 4 nanometer. 10 to the power minus 4 nanometer. That is how its wavelength varies. Okay, the frequency ranges from about 10 to the power 16 to 10 to the power 21 hertz. Okay, that's a very high frequency, and knowing that E is equal to h nu, and nu being so high, h is your Planck's constant, that hence these rays are extremely energetic. They are extremely energetic. Okay, so much so that they can destroy the living tissues. Destroy the living tissues and organisms. Hence, exposure to them should be limited. Actually, none at all. You should not get exposed, but the trouble is they have medical applications, so one just cannot keep away from them also. Fine. So
Necessary evil.
yeah, it is kind of a necessary evil, right? Now, how's it produced? It is produced by striking a metal surface by high energy electrons. By high energy electrons. Okay. If this is say 10 to the power 23 I'll skip 1, 10 to the power 21, 10 to the power 19, 10 to the power 17. This is frequency in hertz. Okay, this is 10 to the power 15, this is 10 to the power 13. Okay, 10 to the power 15. Okay, so okay, and here somewhere here from 14 to between 14 and 15 we have the visible range, right? Between 14 and 15 we had the visible region, and okay, above that you have ultraviolet till 10 to the power 17. Okay, and there is an overlap with the X-rays. So X-rays are from here to here. X-rays, right? While this is your ultraviolet. So this is 10 to the power minus 6, this is 10 to the power minus 7. This is our wavelength in meters lambda. This is nu. Okay. And this is the wavelength of ultraviolet. Okay, so we are talking about our X-rays. Fine. This is 10 to the power 9 minus 9, and the X-rays, they go from here, from somewhere here till 10 to the power minus 10, 10 to the power minus 11, 10 to the power minus 12, 10 to the power minus 13, 10 to the power minus 14. Okay, so somewhere around 10 to the power minus 13 till here. Okay, so these are our X-rays. Fine. So they are highly energetic. So uses is primarily medicinal. Okay, used to detect the anatomy, especially fracture in bones. However, fracture in bones. How does it work? You hit a photographic plate, it will get darkened. If the bone is in front, that part of the plate is not darkened. Fine. So what happens? You put the plate below the bone, take the X-ray, the bone absorbs it, does not let it pass. So that part of the plate remains light